Hi, I'm Eiko Fried. Today I will give a lecture about network theory and network methodology with a focus on challenges and future directions. There are no prerequisites for this lecture, but it is helpful to have a basic idea about network theory and network psychometrics. I posted links to 3 helpful online resource collections here. And yeah, if you have a basic idea about these, you will have an easier time following this lecture. The slides can be found online on the OSF or following the QR code that you can see on this slide. The talk is structured into 4 elements today: 2 broad sections on a number of problems, and then a second section on lack of theory, building, and testing, based on a paper I've written in the last year. The second section is split into a couple of subsections. The first section is more related to concerns that give me a headache and keep me up at night. And we'll start just with the first section right now, that I have entitled A Whole Bunch of Issues. So you all know, if you watch this lecture, that there's something we call network theory, where the idea is that psychological constructs such as personality or intelligence or a mental illness like depression come about as an emergent property due to interactions of components of the system. This is embedded in a much wider framework of complexity theory in general, but I wanted to reiterate this very briefly before moving forward. And talking about moving forward, Angelique and I wrote a paper on challenges and directions for network theory and methodology a few years ago. I don't want to give a talk about this paper today, although it lays the foundation for what I'm talking about today. We laid out 6 problems back then. I would say all of these are still unaddressed largely, but today's talk does not cover all of these 6, and instead I want to focus on a few things that are on my mind 3 years after writing that paper. And I want to start with the topic of measurement that I've been concerned with for a while. It's not really clear what it means in the context of network modeling. At least there are many complications. And here's sort of a brief summary of measurement in psychology in general. I think it's an underappreciated problem, and I think we need to think about it more. And this also pertains to those of us who do network psychometrics. Now, one problem is that we rely on unvalidated items or items validated for cross-sectional assessments. If you use EMA, for example, to query participants 5 times a day for 2 weeks about how they feel, the items that you likely use are from a scale that has been validated in cross-sectional data, and you rephrase the scale from in the last 2 weeks and to in the last 2 hours. We don't know if that makes it a valid item. We don't know what the properties of these items are. We haven't really done much measurement work on items like that. Of course, similarly, if you use a psychometric scale where the idea of the scale was to measure a latent variable, it often has multiple items that are phrased in a very similar way. And then the question is, does that scale really lend itself well to network psychometrics? Another topic is response shift bias. If you ask a person 100 times, how sad are you right now, over the course of 3 weeks, it might well be that this person changes their anchor of what a 3 means on that item. And there's a lot of work on response shift bias, but I have seen very little work in sort of EMA, ecological momentary assessment, time series, repeated measures in psychology, trying to find out how severe this problem might be and how to counter that. I think we should think about that more. In general, what items should we query participants and what items should we model? What are good items for specific disorders and for specific people, and why is that the case? So first challenge, measurement, and I think we need to think about that more. The second challenge is the idea of systems and taking that idea seriously. Here's a very rough depiction of the weather system, of all the components of the weather system, of all the relations and causal influences. And I don't think network psychometrics has sort of embraced this complexity in a reasonable way. I don't think modeling items of the Beck depression inventory are the same as trying to understand a complex system of a mental illness. And so there are some questions here, such as what elements belong to a complex system? And if you think of standard psychometric approaches to scale construction, so we come back to measurement for a second now, on the right side, you can see a common scale for psychology. It's a construct like neuroticism, for example. And we would generally ask a number of questions that are very similar. I'd like to go to parties. I like to go out. I like to drink alcohol. And we would then fit a factor model, for example, as you can see on the right side. And you can see that one of the items has a very low factor loading. And traditionally, that would mean the item is a very bad indicator for the latent variable. It measures neuroticism very badly, right? And so in scale construction, we would usually remove that item from the scale. It's a bad item. And that in turn would increase the reliability of our scale, like Cronbus alpha. But if you depict the same data here, from which I simulated this example, from a network perspective, you can see that in this case, the item x1, the one we would remove from the scale, is actually the starting point of a causal chain that leads to a causal process. And of course, removing x1 from the scale and not asking about it anymore would probably be a terrible mistake. And so I think we need to ask ourselves more, what do we want to measure? How do these systems look like? And what elements belong to a system? That's not an easy question to answer, but I think we need to think about that a bit more, rather than just including items that belong to a certain scale. Because truth be told, these scales were not made with a network perspective in mind. A related question to what elements belong to a complex system. Here you can see a number of items in two scenarios. In the first scenario, items 1 and 2 are highly related with each other. In the second as well. And this pertains to the question of topological overlap. So the idea here is that two items can be highly correlated for two separate reasons. The first reason is that the overlap comes from the fact that they're the same thing. So maybe you measure sad mood twice and you use the CESD scale, which has items on sad mood, depressed mood, and feeling blue, right? So these are tapping the same item 3 times, in this case twice. And we probably don't want to do that from a network perspective. But you can now, and in this case, you end up with the left side where the two items are structurally interchangeable. So you can see that both items 1 and 2 have the same relations to item 4 and the same relations to item 5, which is called topological overlap in the broader network literature. And that is an indication that it might be combinable, that we might want to merge item 1 and 2, or do some other operation on these items. On the right side, you have a scenario where items 1 and 2 are also related to the same way, strongly related, but they have differential relations to other items in the structure. And this means a lack of topological overlap. And this means that we might want to retain both of these items because they carry important structural information in the network. This is a fairly novel idea. Giulio Costantini has sort of translated this into the network psychology world in his PhD on personality, but I haven't seen this being implemented broadly yet. And I think it would be a nice step forward to thinking about measurement and what belongs into a system. Here's a paper that I contributed to as the analyst, and I want to call out that paper and not other people's papers because I don't think we should have done that. So I was approached to fit a network model in about 20,000 people. I was very excited about the big data set, and I fit the network model, and I found that some of the items had really strong links to each other. And so then only then did I read the questionnaire, which the data set was fit upon. And these two items here are, do I often feel that other people have it in for me, or I often feel that others have it in for me, which is pretty much exactly the same item, right? And that's a bad idea to include both of these. And so while the network looked pretty with all the individual items, we ended up only including subscale scores. So there were 9 subscales in this data set, and we used subscale scores rather than individual items, which made more sense here. Another point about complexity in systems is that we really need to go beyond psychometric assessments. If we take depression as a complex system seriously, we need to model biopsychosocial complexity. This is a paper where we try to model DSM symptoms for depression, but also covariates such as age, BMI, and so forth, and inflammatory markers, here depicted in orange, which have been linked to depression in the prior literature. This is just the starting point, of course. These systems are much larger, but I think it's a good step forward. This is a paper by Eva Hilland, who combined a network model of structural brain data and depression symptoms and found some links between these distinct sort of biopsycho areas. Don Robino and I are currently collecting a special issue on the topic of complexity and mental health research. And so if you have a paper to submit, feel free to send it our way, and we can see if we can make it work within that special issue. And the issue will be open for about a year from now on when I give this talk. One of the last points I wanted to mention in the introduction on sort of diverse thoughts is the time frame of dynamic processes. Many of us fit models like the VAR model, right, where there are clear equidistant time points. We measure 5 times a day on smartphones how people are feeling, and then we use VAR models to fit the data. But it's of course plausible that different items that we measure have different time processes. Some items move quickly, some items move slowly. And if I look at common EMA batteries, common studies, including our own, not all of these items appear to have the same sort of time resolution, right? Emotions like anger might resolute in a time frame of a couple of minutes. People are rarely angry for a day. And that also means that the causal impact would probably be limited. But things like insomnia, I mean, they occur at best once a day usually, and these processes are probably much longer time processes. And that means it's challenging to include anger and insomnia in the same network model. And here's a nice graph by Matti, who shows that depending on the resolution of time points, you can get dramatically different information from the exact time, from the exact same data. And Don Robino and colleagues have been working on a formalized theory of panic disorder. I'm going to get into this in more detail later on in the presentation. But basically, you have a box that depicts the slow-moving processes, and then you have other processes the box is the fast-moving processes, and then you have other processes that are sort of slow-moving. And I think it makes sense for us to think more strongly about the dynamics in which processes move along. And if we really want to use network approaches for informing therapies, I think that's of crucial importance. One of the last points here in the first section is the integration of common causes and network theory. I'm going to talk about this in some detail later, but to me it's obvious now, after a few years of working on this, that both common cause theories and network theories are trivially true. And that the truth is in the middle somewhere. So we know that trauma is a common cause for PTSD symptoms, experiencing trauma. We know that early adversity or life stress is a common cause for numerous depression symptoms. We know that there are many transdiagnostic risk factors that cause or contribute to psychopathology broadly. Neuroticism, maybe attachment, early adversity. It predicts anxiety disorders and mood disorders and other disorders. So both are true, and I think the sort of heated and contentious debates, which one of these is better, has hindered us in making meaningful progress towards understanding or building theories that encompass both networks and common causes. So on the left side here, for example, you have an example of a case where there's a common cause and it triggers 2 symptoms 1 and 3, or 2 problems broadly. And then during the maintenance of the disorder, a network takes over and other symptoms are being activated. Another scenario is where you have a common cause that is not once like a trauma, but it's a repeated common cause that keeps activating problems. That could be a job that you hate or an abusive marriage that you're stuck in, something like that. And so I think we need to integrate common causes and networks more in our thinking. Now, some people argue that network theory is in principle superior because common causes can be embedded in a network. I'm agnostic towards that sentiment. Last point in the first section is a point many have made before, so I'm not going to go into detail here. I left some references at the bottom. Most network psychometric models people are using today, I think Don Robino in his review paper 2019 in Psych Medicine found that about 80 or 90% of network psychometric papers so far are fit on cross-sectional data. So these are between subjects models, but inferences that people draw are often on the idiographic level, on the within person level. And that, there are cases and assumptions, if they're met, then this is warranted, but it's a pretty contentious debate whether these assumptions are ever met. And I think we need to think about that more clearly. If you really want to inform therapy for a person, you probably want to measure that person and model that person rather than gaining inferences from a between subjects model. Okay, that's the first part of the lecture on challenges to the network approach. I'll be back with the second part that is about theory building and testing.